Hello, I'm William, and today we'll be working on trig identity and Riemann sum for BC calculus. I hope you have first watched Joe's video before looking into mine because it will really help you understand the integrations I'm doing with trig identity in terms of U sub and by parts. Without further ado, let's get started. So first, let's start with the definition of the integral. The integral of cosine dx is sine x plus c. It's better to remember this. And then you need to notice that the derivative of sine is cosine and that the integral of cosine is sine. So this is kind of like a reversing bridge from one to the other. You derive from sine to cosine and integrate from cosine to sine. Next, we work with the integral of sine dx, which is negative cosine x plus c. And the same as the one above, the bridge method. So the derivative of cosine is negative sine, and backwards, this integral of sine is negative cosine x. Remember the sign changes when you derivative or integrate cosine. Next, this is another one that's on the equation sheet, one that you have to remember. You have been proven to you. Don't ask why, just use it. And then we could see that if you take the derivative of tan, it's secant square, and if you take the integral of secant square, it'll be tan if you follow the formula equation. And then later, another one on the book, it would be tan x dx, which is equal to sine secant x absolute value plus c. This is because the inside of a natural log cannot be negative, so then we need to put a natural absolute value in between it. This is a definition of another integral, which is secant tan x dx equals secant x plus c. Same with the last one, just remember this one. Now that we're done with the definition, let's start with examples of integrating with trigonometry identity. So sine 3x dx, looking back at what we have established earlier, that would be the negative cosine x plus c. And then don't remember the 3x that's below sine x. We'll need to, with derivative we times 3, but then with integral we do the opposite. So we times 1/3 after we have integrated the inside, which then it becomes 1/3 cosine x, but then we need to remember that the negative sign, because as we can see, that's the definition with sine, the integral of sine x dx, it's negative cosine. So then we keep the 3x inside as it is, and then plus c, and then that would be the solution of our first example. Okay, next move on to the second one. The second example, we have another problem. In here, it's gonna be the integration of tan 5x dx. And then if we can remember from what we have established earlier in our definitions, the integral of tan 5x dx would be the natural log of secant x plus 3, and then don't forget that the 5x, again, we have to do something about it. So as I mentioned earlier, we take the opposite of what we do with the derivative. So we times 1/5, and then we just put secant in the natural log of secant 5x, because we keep the inside the same 5x as it is, and then plus c, and then that would be our solution. So the important thing is that when you're dealing with this tans and cosines, you integrate inside if it has something, and then you just follow the definition as we have established earlier. So now this would be example 3. We're working with 5 secant 4x tan 4x dx, and then we take the integral of that. So then from the earlier established definition, that would be secant x plus 3, and then remember the secant x derivative is secant x tan x, and then we just know that, so then we do the opposite. So that will become 5 with the 5, the coefficient, it doesn't do anything with the integral, so we take it out of the integration because it wouldn't affect, and then we just focus on secant 4x tan 4x dx, and then that would be just in its... Wait, but before we hold on with the definition, we need to remember that with chain rule, by integrating that, we need to divide 4 to our outside, and with that, with 5, it becomes 5 over 4, and then we just follow the definition, which is secant 4x and then plus c. That'll be done for our example 3. To confirm if we did it correct, we could always do the reverse of it. You could do this in the exam if you feel that you have enough time, but this is just to check that you've got it correct. So the derivative of 5 over 4 secant 4x, so we differentiate that in order to get what we've gotten earlier, and if it matched, then we've got the process correct and our solution is correct. We ignore the c because if we derive a constant, it's always going to be 0. And then with derivative, we take the secant 4x, the 4 inside the 4x out, and then the 4 in the denominator cancel out because 5 over 4 times 4, that would be 5 secant 4x tan 4x, which is equal to our original. So now we've done with the third one. We'll do one u sub, one by parts using trigonometry identity. The first would be the u sub that we're doing, and then with this function, when taking u, we let the u to be the power of the e, which is 4 plus sine x. And then with that, we can take du, which would, and then we remember that the constant kind of cancels out, so that would just leave us with cosine x dx, and that would be our du. And then by doing that, we could sub for u. So then our new integration would be e to the u power, which the u replaces 4 plus sine x, and we notice that cosine x dx would be equal to du, so that leaves us with a beautiful equation of eu du, the integration of eu du, and that when we integrate it, we need to, some would like ask about the chain rule, that it's 4 plus sine x, and then now that it's u, do we still take the chain rule? But since we're working with u, we just treat it like a constant, so we drag down, what we drag down would be like a 1, so it doesn't really affect, and with eu it stays the same. So that would just be e to the power of 4 plus sine x plus c, and then that will just be our solution. Now let's move on to the other one, by parts, but before doing that, we have to establish the definition of a by part, and then that we can find out in the BC cram sheet as well. So that will the integral of u dv equals to uv minus the integral of v du. In this example with by parts, we usually assign u to the ones that could get simpler by deriving it, and that would be x. So then by deriving it, du would just be dx, and respectively we put dv as sine 3x, and then we integrate it to find v. In the previous example, we have already established that the integral of sine 3x equals to 1 over 3 cosine 3x negative, so then now we just follow the definition of integration by parts. So uv, that will be equal to just 1 over 3 x cosine x, and then minus the integral of v du, and then we just input for that to get our solution in this by parts trigonometry question. We just integrate this, simplify, and then that'll be our solution. I won't bother doing it here. So